everyone. Welcome to episode number 603 of this here electronic engineering podcast called Amelia's Weekly Fish Fry. Brought to you by eejournal.com and written, produced, and hosted by me, Amelia Dalton. My guest this week is Dr. Houman Zarrinkoub, Principal Product Manager of Wireless Communications at MathWorks. Houman and I investigate why the adoption of AI native technologies are necessary for the development of next-generation wireless standards. The steps involved in designing and integrating an AI native wireless system, and the common hurdles that engineers face when integrating AI into their wireless system design, and how they can overcome those challenges. Also this week, I examine a new generative AI tool developed by MIT that can let you have a conversation with your future self, or at least a potential version of yourself in the future. But first, please welcome Houman from MathWorks. Hi, Houman. Thank you so much for joining me.
Pleasure to be with you.
Excellent. Okay, so we're talking about building AI native wireless systems today. But first, Houman, why is the adoption of AI native technologies necessary in the development of next generation wireless standards like 5G Advanced and 6G?
Yeah, if you work with the industry responsible for wireless communication and you look at their publication and their research and what they're saying, AI is becoming not a nice to have feature of the future wireless communication, but a must have feature. And they talk about the reasons why this is happening. I think I can summarize it in twofold. One is the notion of resource allocation. The number of users are exploding, the number of different, beside people talking, cars are talking, autonomous driving, and other IoT devices. So when you have this growing, exploding set of users in the wireless communication, allocating resources, giving the right frequency and the right bandwidth and the right information to them becomes a multivariate and nonlinear problem. And AI thrives on multivariate nonlinear problems, meaning if you give AI enough data, it can find the best way you can give each user the optimal resources. That's one of the reasons AI becoming must to have. If you use traditional approaches, there's just too many parameters and too many things to worry about. A typical traditional approach will not be optimal. That's one reason. And another reason is that the future expectation of 5G and 6G has increased. It used to be I am walking around with my cell phone, and if there is a cell tower and I can talk to my family and friends, I'm happy. Now everybody wants, no matter where they are, in the middle of the ocean, in the middle of desert, on the moon, they want to have the best possible connectivity to internet. If you have such a raised expectation, the wireless system has to know where you are, how you are, and that adaptability, constant customization and adaptability is only possible if you use AI-based systems.
That makes sense. Now, what do you think are the benefits AI native systems offer over traditional models in wireless engineering?
Essentially, I call it scale and that customizability, meaning that if you want to have a system, a wireless system that can handle anything you throw at it, lots of people coming to the wireless system at the same time in urban areas and occasional people coming in and in suburban and so on. And if you have that kind of a need, you have to have a system that can handle scale. And that's where AI native system can provide much better scale than traditional models. And I told you, through learning and adaptation, which is a definition of machine learning and AI, the system can customize wireless communication engineering for you, whereas traditional models are essentially best effort. I think the average user needs this. Average user can benefit from this. I give the average. So if you want to be average, you go traditional. But if you want to be customized to anybody's need, go with AI native systems. That is the main benefit of AI.
Houman, walk me through the primary steps involved in designing and integrating an AI native wireless system.
It's a 4-step process. We learn it from our customers and we describe it to our customers. Data is the major part of any AI system. AI systems with insufficient data is not deployable. It's not even worth anything for you. So the first step of designing and creating an AI-based system is data generation. Now, data has to be the kind of data that reflects and represents the statistics of the underlying things you are encountering. So if you are using AI for wireless system, the data that you gather must be realistic 5G, 6G, Wi-Fi, satellite communication data that you can gather over the air, right? But always, these things may be not sufficient for you. So you must create what we call synthetic data that have the same statistics as this data. So you have to have live over-the-air data as well as synthetic data, and a large set of them to be able to start the process of designing AI-driven systems. Number one, data generation. Number two, you need a representative model. So a lot of people have learned that AI and machine learning is an offshoot of mathematical discipline called statistics. So in statistics, again, you try to essentially match the distribution of data, and you have to have models that can handle that. Now, you have data, you have the model, you train it. So it's a learning process. And during the training process, you let the data inform this model what is the nature of the stuff you're trying to model. So you need large data sets to be able to do that. What is the problem there? Not only you'd have to have a large amount of data for the most probable occurrences, the actual mean and averages, you have to have enough data for the outliers. If you don't have enough data for the outliers, then your system is skewed, your system is biased. So you have to have good models, lots of data of multiple sources and representative. Third steps is after you design and train this AI network, you plug it in and you use it in real-time operation. Is that trained network good enough or not? For that, you cannot use the same data as you used during training. That's cheating. So you have to use fresh data from the environment that you're testing. That's called inference or validation verification. After all of that is done, you have to program it into a program, either on hardware or on software, and deploy it onto devices or internet and so on. So the 4 steps are data generation, model training, AI training, inference and validation and verification, and finally, deployment.
So, Houman, what are the common hurdles engineers face when integrating AI into their wireless system design, and what can they do to overcome those challenges?
Again, I give you 3 words for it and I elaborate on it. Reliability, adaptability, and robustness. What am I talking about here? The hurdles or the challenges is that if you use AI without enough data, synthetic and over the air, you cannot ensure reliability. So you design a system which is not reliable all the time. And that is a major problem because AI systems optimize everything internally, and there is no explainability because it's not made of little modules that humans put together and they can identify where it went wrong. So explainability is a hurdle. It just takes the data, makes the model, and subcomponents are not readily identifiable. So lots of data, lots of rigorous training, that's one of the main hurdles. The second hurdle is that I told you AI systems, machine learning systems essentially match the underlying statistics of the system? What if these systems and underlying stats continuously change? So you have to have adaptability. You have to have AI models that as you use them, they keep adapting themselves for the changing underlying stats of the data. And then what if you have a place where the AI system fails? You have to have mechanisms that make disastrous outcome less likely. So you have to have robustness, they call it in engineering. So these are the things that an engineer worries about, especially in AI design systems, that is much more pronounced and important than traditional systems.
All right, Houman, it is time for your off-the-cuff question. So if you could have one meal right now, doesn't matter if it's on the other side of the world, you need a passport to get there, what would you have?
My favorite meal of all time is Chateaubriand. It's a kind of a steak that is very French, very wonderful, with some kind of a nice potato on the side and a wonderful salad with very creamy dressing. This is the kind of a meal that I go for if I am supposed to answer that question.
I love it. That sounds absolutely wonderful. Well, Houman, I think that's all I have time for today. Thank you so much for joining me.
My pleasure. Thank you so much, Amelia.
If your future self could tell you one thing right now, what would it be? Who to bet on in the World Series? Okay, sure. Valid. Sounds like a subplot in a sci-fi movie you have undoubtedly seen, right? Well, it may be closer to reality than a movie script. Now, get this. A team of researchers at MIT have developed a new generative AI tool called Future You that enables users to have simulated conversations through an online text-based platform with a potential version of their future selves. Okay, so the goal of this system is to help young people improve their sense of future continuity, which is a psychological concept that describes how connected a person feels with their future self. So, research studies about connecting our present with our future selves isn't new. Early methods dating back to the 1960s had people writing letters to their future selves. And I definitely did something like that in high school. Recently, however, researchers have used newer technologies like virtual reality goggles to help people visualize interactions of themselves in the future. But none of these efforts were interactive. Until now. Building on generative AI and large data models like ChatGPT, this team from MIT thought that maybe they could make a simulated future self that could talk about goals and aspirations through a normal text conversation. And that's what they did. So, Future You uses a large language model that actually draws on information provided by the user to generate a virtual and relatable version of that person at the age of 60. Okay, so this is how it works. First, a person would start by answering a series of questions about their current lives, including their goals for the future and stuff that's generally important to them. From there, Future You uses this information to create what researchers call future self memories, which gives a backstory from which the model pulls from when interacting with the user. From here, people can actually work with Future You in two ways: through introspection, when they think about their life and their goals as they construct their future selves, and retrospection, as they think about whether the simulation reflects who they see themselves becoming in the future. And get this, to help with the visualization of their future selves, Future You also generates an age-progressed photo of the user. Future You is also designed to give answers like, "When I was your age." to provide what they describe as an actual future version of the individual. Okay. So, as you can undoubtedly imagine, what if this chatbot starts to go in the wrong direction? Well, this team from MIT thought of that as well. They built in precautions in Future You that shows only one potential version of that person's future self and reminds users that they do have the ability to change their lives. Now, I hear you loud and clear, my fish frying audience. How did they test this platform? Well, this team from MIT conducted a study with 344 people, and the people that used Future You, based on a statistical analysis of their responses, were able to build a closer relationship with their ideal future selves. These users also reported less anxiety about the future after their interactions. And they also said that the conversation with Future You felt sincere and that their values and beliefs seemed consistent in their simulated future identities. So, moving forward, researchers plan to fine-tune the ways that they establish context and prime users so that they have conversations that build a stronger sense of future self-continuity. They also want to study specific applications for this tool, like encouraging people to visualize how their everyday choices could impact climate change or explore different careers. Very importantly, they are also adding safeguards to prevent people from misusing the system. Sure, XYZ company, please make me a Future You version of me who is super happy with my new purchase. Patty Mays, who is part of this project, explains the future of the tool like this. We don't want people to become dependent on this tool. Rather, we hope it is a meaningful experience that helps them see themselves and the world differently and helps with self-development. Wow. Okay, so if you want more information about this Future You tool developed at MIT, to read the associated research paper, or for more information about how to apply artificial intelligence techniques to wireless communications applications with the help of MATLAB, I've included several links under the player on this week's Fish Fryin' page on eejournal.com and in the description for this week's YouTube episode as well. Hey, have you checked out EE Journal on social media yet? Well, you should. You can find us at facebook.com/EEJournal. If you're into X, you can monitor our tweets at EEJournalTFM. And don't forget, if you would like to follow my personal account, check out Amelia D. 1978. And hey, if LinkedIn is more your thing, I dig it. You can follow us or me on LinkedIn as well. And we are now on Blue Sky Social and Mastodon too. We also have a YouTube channel, youtube.com/EEJournal. Folks, it is chock full of all kinds of techie videos, including our very popular Chalk Talk webcast series, hosted by me, and our brand new animated series called Libby's Lab. And of course, you can subscribe to our EE Journal YouTube channel as well. Make sure that you subscribe to this here podcast on Spotify, Podbean, Apple Podcasts, YouTube, or just about any other podcasting platform to listen to some exciting upcoming episodes. Thank you everyone for tuning in. If you know of any cool new technology or heck you just want to chat, shoot me a line at Amelia, that's Amelia, at eejournal.com, or post a comment on our forums on EE Journal. For the week of October 11th, 2024, I'm Amelia Dalton, and you've been fried.